Hello, and welcome to the, hopefully final part number 4 of the series on live coding version key value stores for Kafka-streams-Cassandra-State-Store. Okay, let's head over to IntelliJ and get started. In part 3, we left off with a complete implementation of partitioned of integration tests for the partitioned versioned key value store. So in a test-driven fashion, we have implemented the new test first, though this new test right now is still using the official RocksDB persistent version key value store, and obviously we will need to switch and swap that out to our own implementation with CassandraStores. So I think that's a good place to start. We have our main repository, main package, main Gradle module. We have a repo package, and we have our interface for CassandraStores. Also, class CassandraKeyValueStore iterator. Let's see what we can reuse, and let's see where to start. I think the actual place to start is the CassandraStores class, which is essentially the equivalent to the official Kafka-streams-stores class, which provides versioned or store suppliers essentially as static methods. So I think here we would actually need to add a new method. Let's see. Well, we have a builder pattern, so it's slightly different. But I think we can keep all of those builder options, obviously, and then here at the end we have a partitioned key value store method right now and a global key value store. And we would add here, let's just start. We will provide version key value stores also in the partition and global fashion, but let's start the partitioned one. I think I'll put it at the bottom. And we should here have probably a version key value store supplier. There's only a RocksDB one. Okay, didn't autocomplete properly, so I think that's the one we need to implement. So this would be a partitioned versioned key value store, and we'll need to implement a versioned BytesStore supplier. Let's see what we need to pass in. I think what's different from the other store types is that we will need to pass in history retention in milliseconds. This is long, so I think we'll need to pass that in here. Or that's like a mandatory field. Well, not here, sorry. Here. The name we already have set via the store builder. The metric scope, probably also the same, will be Cassandra. Maybe we should that a static field actually. And I think we, with that, can also use it. Already place it everywhere? No, here's another one. Strange. Okay. Obviously, here we pass through our method property. And I think that leaves us with get method, where I'm wondering key value store, surprised that this simply returns key value store and not a versioned key value store. But yeah, anyway. So I think that's a good place to start. And we should be able to already adapt our test here. So here we would say CassandraStores builder, where we pass in the session and the store name. And we would say partitioned version key value store with here our duration. I think we should change that. Change it to duration. So I think here we will say history retention. And obviously then here we will use 2 millis. And with that, our test already has been refactored to use the CassandraStores instead of the official RocksDB implementation. And that's all done and changed. Ready to, well, run those tests later once we have first implementation ready. Okay. The first layer is done. Now I think next comes a similar implementation to this class, where we say we now create CassandraKeyValueStore. We create a new class CassandraVersionedKeyValueStore, which also will implement CassandraState-store, and in addition a VersionedKeyValueStore, which should also probably be bytes and byte array type. And with that, I think we'll simply start with all methods and then see what comes next. I think the first step should be probably to provide all of those defaults similar to here and a constructor. So I think I'll simply go ahead and just copy paste all of that in. Replace the logger class, obviously. We'll have a Cassandra KeyValueStore repository, so we'll have here a Cassandra versioned key value store repository, which does not exist yet. That's going to be the next class we need to create. And I think that we can drop for now the state store context. We are going to need partition as well as all the position. We need to check if that's also included in the RocksDB implementation. I would guess so. The open part probably will be the same. So here we have our constructor, store name, repo, and that should be, well, the first part. So let's also create a new empty class for that repository and import. And that's the next skeleton ready. And not sure what to do first. I think let's go for CassandraStores and say return new CassandraVersionedKeyValueStore. I think we're probably going to also need the history retention. That's also just used duration. So I think going back in here, we should have probably duration history retention. I hope I'm not too eager that. Let's just hope I'm not. So we'll need to pass the name. And create a new CassandraVersionedKeyValueStore repo. And now it's complaining. CassandraVersionedKeyValueStore that implements VersionedKeyValueStore. All this only extends state-store. Surprised. So we have an interface VersionedBytesStore supplier. And we have a RocksDB VersionedKeyValueStore supplier. That uses a VersionedKeyValueToBytesStoreAdapter. Well, that's somewhat odd. I'm not quite sure what the implements VersionedBytesStore. Value and timestamp. Timestamped bytes store. The friendly version store interface to value store. I wonder if we can also use this actually. It's public at least. IntelliJ to find that setting doesn't. Where was I? Okay. It doesn't keep the ones open that are not explicitly marked, which is, I guess, a good idea, but sometimes it breaks the navigation. Okay, RocksDB versioned KeyValueStore supplier. Here I wanted to see the RocksDB version store implements VersionedKeyValueStore bytes. So same as I was planning to do here. Yep. Okay, so this means we should be able to also wrap our store with this adapter. So let me try to do that in here. And that would mean just going to wrap it like this. So it's a versioned KeyValueStoreAdapter wrapping CassandraVersionedKeyValueStore, which also receives the CassandraVersionedKeyValueStore repository. Fancy. And yeah, here we'll have to pass it. A session and all of the other goodies, which we will get to in a bit. And we'll also need to provide Java docs. That's a to-do for later. And I think that's our next step done. So I think apart from the Java docs, and I'll need to pass through parts into the repo. That's the next step completed. So we'll need to get on, obviously. Here, this is just a skeleton, empty template, and this one anyway. I think here we can, what's the next step? Let's just do the basics for the repo first. So here we have an interface for our KeyValueStore repository, which we cannot reuse since that's definitely different from the versioned methods we will need to cater for. But the abstract CassandraKeyValueStore repository, do we need to name that KeyValueStore? Don't think so. I think here we can start to make it a bit more CassandraStores repository. And we're not going to rename them. So only this abstract class will make it more generic from the name. The name more generic. And the next step would be to add a new interface CassandraVersionedKeyValueStore repository. Yeah, exists already. Let's first rename this one into, no, let's simply make this an interface. And let's create a new Java class Cassandra partitioned CassandraVersionedKeyValueStore repository. That's a long name, but let's stick with that. I think there's something blocking us from using such a long name, but it's long. Okay, and that one implements CassandraVersionedKeyValueStore repository. And here we obviously now got a problem because we somewhere have used that with a new to construct this, which obviously is not going to work. But instead we're going to construct the partitioned CassandraVersionedKeyValueStore. Okay, and this one implements our interface, but it also extends the abstract repo. And the abstract repo takes, what is that, the key? Why does it need, what does it need that key for? Value key. Okay, guess it's to be generic. So you partitioned should be like this, and we need to implement methods, and we need to also override implement. Okay. Well, yeah, I think probably those two, and we'll need a constructor as well. And let's also take that logger. Let's just copy a first prepared statement as well. And the constructor. And I think here we should also need our operation history retention for maybe not. Maybe we should pass that through on demand. But I think it's also static, so it won't change. No, but I think the validation logic should be done not in the repo. I think I will undo that step. So related problem. Okay. Yeah. So session, table name, create table. I think all of those are builder options, table options. Yeah, I think we can keep all of those. And then we can say build create table query. Let's just take what we have here. And now let's look at, let's head over to to the issue on the GitHub repo, where we should have from part 1 our new structure. So we should have partition key from valid 2. Primary key will be this. And then we have, yeah, with compaction. I think this should be part of the table options already. There should be a default somewhere that's going to be passed through. So I think there's no need to do anything else for this method. And I think the init prepared statements will look something like, this. So I think that's, I mean, this is obviously not correct, but we'll address that in a minute. So again, one step back to the Cassandra stores. And here we probably just need to copy paste portion for it's the same for all repos. So yeah, I think that should be how it works. Raw use of parameterized. Oh, why does it not complain here? Not sure. Actually. The global Cassandra key value store is not. Okay, that's always byte buffer. I wonder what if we actually need that key implementation. Yeah, but let's do it like that. And that should be the Cassandra stores now also completely done. So that's our next step. And I think now we're actually getting closer to really adding some implementation details. We already have the first part, which is the create table statement. And I think next would probably be, yeah, I think we should start filling more. Then let's start with the basics here and then start to implement the first method for real. So, okay, next. Let me just open the CassandraVersionedKeyValueStore. Move that right. And close that for a minute. And let's just walk through and see how what we can just probably also copy paste. Let's move the init further up and do that first. First, processor context states store root. I think I will just copy paste this here. Deprecated node stays the same. Use CassandraKeyValueStore init. I think that would make it just a reference to the overloaded, newer, not deprecated init method. And I think here again we can probably also just copy paste, since that will be the same. Then we have close name flush assistant is open. Essentially all of those. And query and get position. All of those as well. I would almost guess that we can copy paste all of those. Though this query implementation, I'm not sure if that's actually going to work. I think if we say here we have versioned well, maybe we do. Let's check our rocks versioned store. Yeah, probably this one. Do we have query implement the query method implemented here? No, it's not overwritten. Otherwise, I would have seen it already. Maybe I had it. Oh. Extend state-store. So it's not implemented for VersionedKeyValueStore. So I think I would probably in here also simply get rid of this, since it's just overwriting the default, and RocksDB is not doing that. We should not have to do that either. And it should complete all of the kind of the boring basics. And with that, I think we finally can get to to that nitty-gritty actual implementation of those 4 interface methods. I think I'll also just reorder those, start with the get methods, and I think on the interface it's also then first. No, I don't know. Let's check. The put is at the top, delete, and then the gets. So it was just like, let's just keep that order then. Okay. I think that's a good start. I will take a 5-minute break and I will pause the recording and be back in a minute for you instantly. Okay. Back after a short break. Let's start with the simplest part. This get method without as of timestamp, just get the latest by key. And I think we can take a look at RocksDB version store for inspiration. Here we check that the key is not null, and we validate if the store is open. And we get the latest. If not null, else we return null. I think we can somewhat just copy paste that into our implementation. Do we have such a validate store open in our Cassandra KeyValueStore implementation? We do not. Maybe we actually should add that, since I'm not sure if private void, if we actually should have that. And I think this we could, well, no, the open is private in this class, so let's just keep it here as it is. And I think latest value and timestamp. I think here now we will actually need to use our repo, where we'll get our record by key. If we check like a get method here, we have a trace log. Also add that. And this returns here a versioned record. And interestingly, the versioned record has a value and a timestamp. So I think we cannot simply return bytes like we do for the key value store, but we'll need to return. Well, maybe we could directly return this versioned record, or we should have an internal representation of our data. I think it would look identical to this. Or, well, I think we will actually need more information for our business logic. So I think we will need our own class representation for this. So let's see what we have in our repo here. Well, we actually only fetch the value from the result. I think that we cannot adapt. We need to do a bit extra for that. Okay, not sure if I'm explaining what I'm thinking right now, but give me a minute and I will clarify in more detail. But I think what I meant is we'll need our how should we call this class? We'll say versioned record. Yeah, that already exists. Versioned entry. And let's create that within the repo. So let's say this will be, maybe it could be a record. Is this valid? Since we are compiling with Java 17, I think we could make this a record. And the version entry would have probably quite a few fields of our underlying table. So I think I want to go, or not here, but here. I think the key we don't need, partition we won't need, but we'll need the valid from valid2, the timestamp, and the value. So I think let's start with the value. And you would be byte array. Then we would have a long timestamp. Valid from, valid to. I think we're gonna need all of those for the business logic. And I think that's probably that. Okay, so we have a version entry. And let's see if those fields, that's gonna work out. But yeah, I think the next step is to, so if record is not null, then we will have a new versioned record. Not sure if we need that. I don't think so. We'll probably just need to do record.value with record.timestamp. And this will be our first method of our interface, which would return a versioned entry and get by bytes. Though, since this is going to be the partitioned, let me double check. Right, the global one always passes or simply does not use the partition. And probably in the global, Yeah, I think it's just ignored. So that means we'll also add the partition here and the key as bytes. And let's, well, straight away also say we also add a long gosh. So many similarly named long as of timestamp. Let's add both of them straight away. And with that, we pass the partition and the key, and we should have our first method implemented, though the repo, the underlying repo implementation is still empty. But yeah, that's again that next layer to implement. And I think probably if we can probably simply copy paste that. And pass as of timestamp. Well, let's also check the RocksDB version store implementation of okay, well, the get as of timestamp is a lot more complex. There's also the validation, and we need to also keep the observed stream time. Okay, no, so why not? Let's try also start with this. So here the key is checked that as of timestamp is not validated other than here. Okay. Latest record version per key never expires. So I think this is fair. Though I'm not sure if we need that warning, but let's say if this, then we should return get by key. For that would mean we would return the latest if it exists, and if not, we would return null, which should satisfy this condition. Yeah. The observed stream time is private long observed stream time. No timestamp is -1. I think that we can probably take to kind of follow. So also put that up here. Well, I guess we could also say we do work with milliseconds here. So we rename that as well as the parameter, and we make that long. And here we say 2 millis. Since, yeah, that's probably also work with long in the table, in the database. I think that's fair. If not, yeah, we might need to change that back. But I think that should be fine. Okay, so we have the get done. Then get as of timestamp. We do a validation. Remove that first. So if you try to get a record before kind of the returns history retention from the observed stream time, then we try to get the latest. If it doesn't exist, then, well, it will be null, but we won't access our repo for that specific record. And the next step, I think we can actually check our part 1 draft of this is the latest record, and this is our point in time record. So I think here we simply need a new method for the repo, and we are going to well, we think I can add that back. This value, if present, is guaranteed to be latest value store. Very latest value. Did I remove too much information? I think here we had some information on history retention exceeded. We still check the latest value. We copy paste this comment. In case, so I think we do need another check. Okay. So if If the latest timestamp is smaller or equals as of timestamp, here we just say versioned record timestamp. Is this correct? Careful. The timestamp we pass in and persist. Do we need to actually check? I think we might need to say we don't use our get method from here, but we use the repo. We also do a null check. And we get valid from. I think that is actually our correct timestamp. If so, then we return our versioned record. And if not, either the record is null or this condition is not satisfied, then we return null. Okay, and if it's a valid request, we query the point in time record if present. I'm wondering if we now also need to always first check the latest record. And if not, query the point in time. Did we put that in here? I think not explicitly. Do we always... Okay, here I'm not quite sure if it's sufficient to directly fetch. I will need to get my head wrapped around that logic first. Need to remember. So if we query as of timestamp, not sure if the performance is better if we do a direct lookup. I would expect that to be more efficient, or should we still do a single query only and see if the I think I will just just stick with that for now and see if that works out. Okay, so that's our two get methods implemented. While here we'll need to double check if we need to query, or if we should do two steps here, or if we should just directly use the more complex query. So yeah, I will keep the to-do and address later. I think, well, let's now, as a next step, before we continue with put and delete, let's do tire effect. Okay. And now let's head over and implement those first two methods simply. So here we need to implement methods, two of those. And let's see, like for the partitioned repo, let's move that to the right. Let me just copy paste that quickly. And start from that. So select partition and key. I think we can rename to select partition and key and valid 2. And we bind partition key and -1. Let's say here we put that as an unbounded, and unbounded we will create as a static, a constant field. As -1. And I think I'm actually going to move it into the interface. Yeah, thought so. Just like this. And in the repo say take unbounded. And I think the remaining parts we can use until here. And here we say this is our value, and we return version entry value, and then result get long long 1, 2, 3. Result get byte buffer. Odd. Why does it complain here? Method call expected. Return new. Okay, that's better. Okay, now we need to properly prepare our select query. So we select the value, time, what's it called? Time field, and then it from to for our version entry from to. So time from valid to, and we need from our table where partition equals and key equals and valid to equals. Okay. Well, as simple as that. It should be our first query done. And our next one, let's start with a query. And let's call that valid to greater equals. Just call it like this. Used somewhere. Okay. Okay. Select the same fields from table where partition and key and valid to. Now we say greater or equals this. Order by valid to ascending, limit 1. I hope all of that will fit into the pad statement, but I mean the order by and the limit clause. Since I'm not sure if that's to be handled also part of the prepared statement, or if that's something that needs to be set on that bound statement. No, but I think that should be similar. So let's again copy paste this. And instead of unbounded, I think we just need to pass in as of timestamp. We would also expect a single result. So just fetch 1. If it's null, return null, and if not, then convert and wrap that as a versioned entry. And I think actually we could do that inline. And we can probably going to need multiple times, let's say, get single one version entry. Well, I think I will just pass in. Let's undo that. Let's say we do like this. Get to versioned entry. Or let's get versioned. Now let's call it to versioned entry. And can also do that line here. All at the same here. Ah. No, right, correct. Just wanted to move that to the bottom. And we need to use this statement. And that's the TDL, not the DML. Yeah, I think that should all be fine for the first two methods. Okay. So next we go back to not the repo, but to the store class invitation. And we are going to implement our put method. And actually the delete thing, we can reuse put with. Now let's do that later, but that should be quick since it's just to put a null value. Or with an empty value, whatever. But if we can pass, I think we can pass null as a byte array. Okay, so put will be more complex. Let's just start. Flow will be slightly different. But the first two steps will be the same. Get current value. So let's again look at our RocksDB version state store version of our put. I think we can start the same grace period. Is the grace period set to? Okay. They considered that. Well, let's follow those steps simply then. So we also have a grace period. Why not? Okay, so we for the put okay, to undefined, that we should also be able to access. So I think well, but not from. And simply use use that as well in our code. Or would that be more clever to? No, let's use that here as well. Okay, sorry, moving back to code put. Here, so we were here. And in our implementation of, not repo, but here of put, let's rename that as well as that to follow RocksDB. We don't have a metric sensor. Okay. So that's the validation passed. Next comes a do put method. segment. Well, okay. So if we will just keep within the same method for now. Okay, interesting. They clean up before processing, so I think we actually should do that as well. So this is actually step 3, step 2, clean up expired records. Yeah, not the repo. Clean up for the observed stream time. And let's create that method. And we also need to pass in partition here. Should we implement that also straight away? Let's keep it with the to-do until... No, well, why not? Let's do it right now. So let's call it cleanup. And the cleanup query is session prepare. Well, simply this, where key equals, so delete from table, where partition equals and key equals, and let 2 smaller or equals this, and when 2 is larger or equals 0. Okay, and I think what was missing for the cleanup was actually the key. So need to also add key. So we clean up a specific key. I think there's no other way to clean up, since we simply cannot run this delete query based on valid 2 without specifying the key. So unfortunately, we cannot clean up like all keys when they are not accessed. But yeah, I think that's, well, it's going to be important to consider, since keys that are not written will not be cleaned up. But I think it's just a small limitation or problem. But remember to, maybe where can I put this? Maybe just here. Okay. So the cleanup should be similar like the insert here. Statement, execution profile name, execute. Cleanup. And we'll pass in bind partition key and our observed stream time. And then execute. Okay, I hope that's correct. I think let's leave it like that for now. So we do the cleanup. Then we get the current value. So sorry. No. Simply using the repo. And then we check if the new record is after the current one. Step 4. Check if new record is after current latest. So if timestamp I think it should also fit if it's larger or equal to the record. Let's call that entry. Okay, I think it would fit in one line, but I think that's better readable. And I'm wondering if timestamp here actually is true, or if that should be the valid from, since that will be the time of record time of insert. I think it should be the valid from. Timestamp is simply going to be always kind of the current insert time into the database. That's not, it's different from the records time. Okay, so we were here, entry. So if the current timestamp to be put is larger or equals the entry valid from, then the new latest. This is the new record as latest, and else insert persist. This is the new record as a point in time entry. Okay, so this here is our first. So we have the next step 5a. We fetch the record as of timestamp. So we get this is latest, old latest, current latest, and this is entry as of timestamp entry and current latest entry. Okay, so we have a as of timestamp entry that should be, that's the same, no difference in query, so we already have that. And with that, we need to start a batch actually, and that would mean we write a new repo repository method for updating how are we going to do this? I think we'll simply write two records in the batch. So I think that would simply mean we say repo save in batch, and here we would have, I don't think we need to use a list on array, but or would that be, I think we can do that explicit. Let's just make it, we can use list order. Arrays as list. And we would need to partition key value VersionedEntry. Should we use a VersionedEntry? Or the partition will also need the key, and maybe we can do it that way to say we have a partition key and then we have new versioned entry. You have two versioned entries, and here we have our value. And so we insert, first one would be the new latest. Which is valid from the time of the current new time. So this is value timestamp. So this is, sorry. So this would be instant. Instant now. Epoch milli. Well, let's see if those time fields, I would actually need to use instants, not longs, but long might also work. Let's see how that's going to work out. Let's use millis for now. Instant now to epoch milli. And valid from is timestamp, and valid to is value. Oh, what was it called? Turn code valid to undefined. Blind here. So this is valid to undefined. Okay, and the value, and then we update the previous current latest entry. Now we update. Yeah, we update the current latest entry. So we use the value of that. We use the timestamp of that entry to not change that. And then it's valid from current latest valid from. And it's valid until our new timestamp. I think that should be that part. And saveInBatch should take the partition key and a list of version entry. And that's a to-do. Okay, so that's one part of the put. And our second part is if it's not after the current, then we fetch we did already fetch did we fetch the did I pick that wrong? Yeah. Okay, so I think we can put this to do here. Or actually, this is here, and here we simply have the description. That's 5a. And for this logic, we fetch as of timestamp, and we think that AB doesn't really make sense, so we also call it the step 5 fetch record as of times. And step 6 would be update the previous record, insert new record. So for this use case, we say stream time 16. So we had a 10 to 15, which you make a 10 to 12, and then we have 12 to 15. Okay, so that first one is actually going to be the new record. Oh, valid from. Sorry, valid. No, valid to here. This is going to be a new record, while it's actually the previous existing one. So we take the as of timestamp entry dot value. The timestamp is as of timestamp and it's valid from previous, and it's valid to our new timestamp. And then we insert a new value, which is valid, which has a new instant now. So new insert timestamp. And it's valid from the new timestamp, and it's valid to as of timestamp entry 2. Okay, I think that should be the logic. And what do we return? The put method returns valid to timestamp of the newly put record. So in this case, we return the new latest, return this record, and in this case, we return the valid to of the previous as of timestamp entry. And with that, we have implemented our put logic, which only leaves one final method to implement, which is the delete. And here we go. So let's first, to clarify our understanding we got from the test, let's again start by looking at what the RocksDB VersionedState-store does. Oh, let's move back and go that way. Okay, so we have a delete. We do a similar check as with the put. We get the existing record. Okay, and we put observed stream time. Okay. I think we can almost copy paste this entire thing. So we check the key, validate the store is open. You return null if we skip, cause expired. And I really wonder if that should be worn log levels here. I think I will make that a delete. Not delete, debug log level. Yeah. I mean, the RocksDB one is Kafka internals. But even that one is, I think, the default. Okay, let's just follow. Let's follow with the log level what Kafka is doing. So, okay, again, we then return null if we skip the record. We get our existing record and we update the observed stream time. And then, yeah, as we expected, we simply run put with the null key. Just think that's not very efficient since we get the existing record up front, which will then happen again during the put. Let's say we put let's also make such internal do put, and in this internal do put current latest yeah, I think let's just remove that step one. 1, 2, 3, 4, 4, 5, and let's make that do put. And I think instead of returning a long, I think I will say we return a versioned entry. And we say that's version entry new entry. New entry is this. Patched entry. Okay, call it new entry and patched entry, and the new entry we are going to return valid 2. So in persistent entry, valid 2, this would be our put method. So, and for the other path, we return the new entry And here for our do put, we simply put in key value null timestamp. And we keep the persistent entry. And we say to version record persistent entry. Wait. We need to not save the persisted, but the previous. A little bit tricky to achieve. Let's call it the previous entry, and we introduce a Boolean to say previous or to always return the previous entry. So we have Boolean as a fourth parameter. This is going to be called return previous. Then we return the patched entry, if not a new entry. And here we, well, essentially the same. I wonder if there's anything we can make more generic. Maybe we can say we have a new entry, patched entry. Will be the same here. I think we would need to be careful if this is null. If it's null, we need to double check what to do. Okay, so for the delete, we then get the previous record returned, and we return that here. Let's quickly check again how this works. Okay, right. If there was the existing record, it's returned, but that might as well be empty. Okay, maybe we will have a slightly more efficient version of that, though it's a bit more complicated. So patch and renew entry. Okay. So in case we do not have an entry at that point in time of the delete, well, of the insert, if the value equals null, then nothing to do. If patched entry no entry so the new entry always is so sorry again. If as of timestamp is empty, so that would also mean, okay, well, the current latest could also be empty. So if current latest entry is null, oh, come on. If the current latest entry is null, then the new entry is going to be let's say the new entry always is this. And the patched entry is null to begin with. So I think then we do not have this edge case if current latest entry is not null, and no, I think if it's null, then empty body. Okay, so if the current latest is null, there's nothing to do. If it's not null and timestamp is after the current latest valid from, that means it's to be replaced. So the new entry will be the new latest, and the previous latest will be essentially a new insert, but yeah, it's going to be kind of a patched entry. Previous will be inserted as a new with new primary key. And if not, that means we need to fetch the as of timestamp entry. Now, if this is null, then we need to yeah, we just need to create a new oh. Oh. It's a bit much logic, and I'm a bit tired. Let's wrap this up now. Concentration. Okay. So if it's not null, then we insert a new record timestamp, but it's valid to the as of timestamp, and the previous one we just patch the previous valid from and valid to this timestamp. If not, then we would still need to create a new entry, and we need to patch current latest actually. So I think the new entry would be this value, which is valid from the current timestamp so no current latest entry. And if value is null, then there also should not be written a new. I think we should still write an entry, so I think that's not correct here. Because if we get then late data, we cannot just lose that delete. So I think also there's no separate to do here. So if we have as of timestamp equals null, we use our current latest entry valid from, so we insert a new historic entry with our new value current time when we actually write that record, and it's valid from the timestamp until our current latest entry. Is this correct? Could there be other records after, like before the current latest, after the time of write? No, it should not. Otherwise, we should have picked that up. Let me check again that valid. Valid 2 larger or equals this time, not smaller, but larger or equal. Then we should still fetch get one if any exists. let me test that logic. I think we still might need to validate if the valid from for the get holds true. Version entry valid. So if it's not null, we patch. I think I might need to play this through again with a few extra tests. I'm thinking too many use cases in my head right now, so which I'm not explaining why thinking. I think what I'm thinking, or what I'm thinking about, is if this as of timestamp entry query actually. So if we use if we say this is valid from 4 or from 10 to 15, and we actually try to insert at time 8, then this query will check with the smallest or the biggest entry, which is smaller or equal, or valid 2 is bigger or equal 8. So it will fetch this one. But since 8 is even smaller than the lower, kind of the valid from of this entry, we cannot just say we change that new record to be valid from the current timestamp to if we insert at 12, then we will need to write that from 10 to 12. No, this one from 10 to 12, and the new one from 12 to do you have any thinking problem? So we insert at time 12, price $12, stream time 16. So we fetch the latest, is valid from 15. So we fetch the record as of timestamp 12. Well, as of timestamp 12 would be this one, $10. Run it from 10 to 15, so we update this record to be valid from 10 to 12, and the new one from 12 to 15. But if we would think it's not so far ahead. If we would have a record 10 to 50, we would insert at 8. We would notice that this record 10 to 15 we can just leave as is. So we would only insert a new record from 8 to 10. So if as of timestamp is empty, yeah, we insert until the current latest. Else, if is as of timestamp valid from, is larger or equals timestamp, then we would say the new entry actually is value. Insert now, and it's valid from the timestamp until as of timestamp valid from. Now I think we do finally have all edge cases. So we say that's step 5A, 5B. 5A means we have no previous non-latest record. Insert new. And we have a previous non-latest record from after print timestamp. Okay, and now I think we only need to say we have a list, array list, or actually I think we would rather say arrays as list. String filter non-null to list. Okay, so we create a stream of this, but then we remove all nulls and we still then save that in a batch. And I think if we now with this validate store open, did I mess up some? Okay. So put says returns a valid to timestamp, newly put record. Put, and if not, it should be the valid to, and the persisted entry return previous. Should always be the new entry, and new entry should never be null. I think that's a given. Only the patched entry can be null. So this can be null. So I think we just need to make that if entry is not null, and if not, then return a new version record. from this entry. And now I think the logic might be complete. I think I'm too confused now to be sure, or not actually confused. I'm fairly sure that it should work, but it's still, I don't know, it's still a lot of edge cases, so I think I better first add additional tests and then just work against the tests to see if we missed something. But before we can go and test, there's one last implementation to be done in the repository. That would be our saveInBatch. I think the first now is to check if more than one entries entry. So if entries size equals 1, I think I'm also going to assert check by non entries. And I think I would also say assert is at least 1. List of entries to assist should always be meta equals 1. Not should, must always be. We should never run into this, but yeah, who knows? So better assert that and have at least some indication and see if we still manage to run into during tests. Okay, so if it's size 1, then we can, there's no need to use a batch, but we can directly say we do an insert. So let's just do similar to here. We would do insert bind partition key instant now. So we would say entries get first one. That's the entry. And we would say entry dot value and entry valid from valid to. Let's put those into separate lines, and this insert, and you would insert Here, I think we can reuse the insert like the saveInBatch here. The insert would be session prepare, insert into table name, and we have partition, key, time, value, but we also have valid from, valid to, time value, and here we also have two more parameters, 6 in total, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's see, maybe we need to convert them. But let's follow here our logic saveInBatch. So let's simply say we have inserts, and for the entries for each we add inserts add insert bind. And let's say if insert size equals 1, then we simply say we have a bound statement equals inserts get 0, inserts bind interesting batchable statement. Okay, I think that's a cast. Okay, let's do that again, roll that back. If entry size equals 1, we do that, and else we do we need to return something? No. Else we do this, inserts, and then we say batch statement add all inserts. So we execute a batch. If not, we execute a single insert. And that should be our implementation for saveInBatch. And I think we are finally at the point where we are complete with the implementation. And it's time to run our integration test, which we might need to add more edge cases, more test cases. But as a first indication, we should now be able to run our test. And cut. Here I need to interrupt. So this is recorded sometime later. I actually did run tests and continue with running and fixing tests. But since the recording simply got too long for YouTube, I needed to cut the entire or split the entire recording into 2 parts afterwards. So with this, I am now wrapping up this part number 4, which covers the complete implementation of VersionedKeyValueStores. So please stay tuned for part 5, where there's more bug fixing and refactoring to be done to complete the implementation to pass all tests. And with that, thanks for watching. Please subscribe, follow, and share. And see you for part 5. Thanks. Bye-bye.